Right now, you're probably driving on ground-up rubber, and you don't even know it. Every year, Americans toss out 290 million tires, like some kind of national rubber ritual. Most of those tires used to end up in landfills, piled up like the world's most depressing game of Jenga. But then some engineers had a wild idea. What if we just drove on them instead? Stick around, because the story of how America turned its tire problem into an infrastructure solution is way more interesting than it has any right to be. Let's rewind to 1990. Picture this: tire graveyards stretching for miles, mountains of black rubber baking in the sun, leaching chemicals into the groundwater. Yeah, months. Because once a tire pile ignites, good luck putting it out. These weren't small campfires. We're talking infernos that could be seen from space, spewing toxic smoke across entire states. In 1983, a tire fire in Virginia burned for 9 months straight. 9 months. That's longer than human gestation. You could conceive a child, carry it to term, and that fire would still be going. The problem was simple but massive. Tires don't decompose. They're built to withstand basically everything: heat, cold, friction, rain, the occasional pothole that feels like a meteor crater. They're the cockroaches of the manufacturing world. Except cockroaches eventually die. Tires, those things were forever. Landfills didn't want them because they'd float to the surface over time, like some kind of horror movie, where the dead won't stay buried. Seriously, you'd bury them under tons of trash and they'd just rise up. Creepy stuff. Full. By the late 1980s, the United States had over 2 billion waste tires sitting around. 2 billion. That's almost 7 tires for every person alive in America at the time. And the pile was growing by 240 million tires every year. Something had to give. Enter the Arizona Department of Transportation. In 1989, some engineer in Phoenix looked at a mountain of shredded tires and thought, what if we put this in our roads? Now that might sound insane. Like proposing we build houses out of old pizza boxes. But hear me out. Asphalt is basically just rocks held together with bitumen, which is a fancy word for really thick oil. It's sticky, it's flexible, and it works great for roads. It cracks in extreme heat. It becomes brittle in extreme cold. It's expensive, and it's not exactly winning any environmental awards. Rubber, on the other hand, is flexible as hell. It handles temperature changes, like a champ. And America happened to have billions of tires lying around doing absolutely nothing except being a fire hazard and an eyesore. The logic was almost too simple. Grind up the tires. Mix the rubber into the asphalt. Boom. Problem solved. Kind of. Arizona started experimenting first because, let's be honest, their roads were melting. Phoenix in summer reaches temperatures where you can legitimately fry an egg on the sidewalk. Regular asphalt would basically turn into tar soup. Cars would leave tire tracks like they were driving through wet cement. Not great. The state needed something that could handle 120-degree heat without falling apart. Rubber-modified asphalt seemed worth a shot. The process goes like this. You take old tires and grind them down into tiny crumbs. We're talking pieces smaller than a grain of rice. This isn't your backyard wood chipper situation. We're talking industrial shredders that can process thousands of tires per hour, turning them into what's called crumb rubber. Then you heat up the asphalt mixture and add the crumb rubber. The rubber particles get coated in the hot bitumen and become part of the road surface. The first test roads went down in 1989. Would it work? Would it fall apart in a week? Would cars just sink? Turns out, it worked beautifully. Better than anyone expected. More durable, and it handled Arizona's psychotic temperature swings without cracking. Plus, and this is the kicker, it was quieter. Driving on rubber-modified asphalt reduced road noise by up to 5 decibels compared to traditional asphalt. That might not sound like much, but 5 decibels is the difference between a normal conversation and a loud conversation. Multiply that across millions of cars and suddenly entire neighborhoods get quieter. California saw what Arizona was doing and said, "Hold my overpriced latte." California was going all in on rubberized asphalt. They don't mess around. We're talking about a state with more cars than some countries have people. If anyone needed better roads, it was California. They started mixing crumb rubber into everything. Highways, city streets, parking lots, By 2010, California was using over 20 million tires per year in their roads. 20 million. That's one tire for every two people in the state, annually. The benefits kept stacking up. Rubber-modified asphalt lasted longer than regular asphalt, sometimes twice as long. That meant fewer repaving projects, less construction, fewer of those infuriating orange cones that turn your commute into a parking lot. It was more resistant to cracking and rutting. You know those grooves that form in the road where trucks drive constantly? Rubber asphalt reduced those significantly. It improved traction in wet conditions because the rubber particles created a slightly rougher surface texture. Basically, it was better in almost every measurable way. Economics. Regular asphalt costs about $40 to $50 per ton. Rubber-modified asphalt costs about $50 to $60 per ton. So it's more expensive up front. But here's the thing. If it lasts twice as long, you're actually saving money over time. You're repaving half as often, which means less labor, less equipment, less traffic disruption, and less money bleeding from state budgets. Plus, you're getting paid to take people's old tires instead of paying to dump them in landfills. Some states even started offering incentives. Use rubber in your roads and get a tax break. Use rubber in your roads and qualify for federal grants. Suddenly, using old tires wasn't just environmentally friendly, it was financially smart. Governments love things that are financially smart. It's like their second favorite thing after ribbon-cutting ceremonies. Other states started paying attention. Texas jumped in. Nevada, Florida. By the early 2000s, over a dozen states were using crumb rubber in their roads. The technology kept improving too. Early rubber-modified asphalt had to be mixed at the plant, which meant specialized equipment and training. But engineers developed a new method called the wet process, where you could add the rubber directly to the bitumen before mixing with the aggregate. This made it easier to implement on a large scale. Then there's the dry process, which is even simpler. You just toss the crumb rubber in with the rocks and mix it all together. No special equipment needed. Any asphalt plant could do it. This democratized the technology. Small towns could use rubber-modified asphalt without investing millions in new machinery. It was the fast food franchise model applied to road construction. Simple, scalable, repeatable. Now let's talk numbers, because the scale of this is genuinely mind-blowing. A single lane mile of road uses about 1,000 to 2,000 tires, depending on the thickness of the asphalt and the rubber content. 1 mile, 2,000 tires. California alone has over 170,000 lane miles of paved roads. If you converted all of that to rubber-modified asphalt, you'd consume 340 million tires. That's more than an entire year's worth of waste tires for the whole country, just for California's roads. Obviously, not every road needs to be rubber-modified, but even doing a fraction makes a huge dent in the tire waste problem. Arizona, the pioneers, now uses crumb rubber in about 2,000 lane miles of road. That's roughly 4 million tires per year, turned into roads. Texas, because everything's bigger in Texas, uses even more. Florida incorporates rubber into their roads, because the heat and humidity down there absolutely destroys regular asphalt. Each state has slightly different reasons, but the outcome is the same. Millions of tires that would have sat in landfills or burned in toxic fires are now being driven on every single day. But wait, there's more. And yeah, I know that sounds like a cheesy infomercial, but genuinely, there's more. Rubber from tires isn't just going into roads. Engineers started getting creative. Playground surfaces, made from recycled tire rubber. Those soft, springy surfaces that keep kids from cracking their skulls when they fall off the monkey bars. Tire rubber. Running tracks. Tire rubber. Athletic fields. Tire rubber. Equestrian arenas. Because apparently horses need cushioning too. You guessed it. Tire rubber. Some companies started making rubber mulch for landscaping, carpet padding, and even new tires using recycled rubber. Because roads are everywhere, they're constantly being repaved, and they can absorb absurd quantities of material. It's the perfect recycling solution. High volume, high impact, economically viable. Of course, not everything was sunshine and recycled rainbows. There were concerns. Some environmentalists worried about chemicals from the tires leaching into groundwater. Tires contain some nasty stuff, heavy metals, petroleum byproducts, Chemicals with names that sound like rejected Star Wars planets. Legitimate concern, right? So researchers studied it extensively. Turns out, the rubber is so tightly bound in the asphalt matrix that leaching is minimal. We're talking parts per billion, well below any environmental safety thresholds. The EPA studied it. State environmental agencies studied it. The consensus was overwhelmingly that rubber-modified asphalt posed no significant environmental risk. In fact, it was way better than the alternative, which was letting those tires sit in piles where they definitely would leach chemicals into the soil. There were also concerns about air quality during installation. When you heat asphalt to 300 degrees Fahrenheit and mix in rubber, you're going to get some fumes. But again, studies showed that emissions were comparable to regular asphalt paving operations. Not worse, not better, just different. Paving crews didn't need special protective equipment beyond what they already used. The health risks were negligible. Some complained about the smell. Hot asphalt already smells like, well, hot asphalt add rubber, and it smells like hot asphalt mixed with a burning tire. Which, fair enough, isn't exactly lavender and vanilla. But construction sites aren't exactly known for their pleasant aromas anyway. You're already dealing with diesel fumes, tar, and the sweat of workers who've been outside for 8 hours. A little extra rubber smell wasn't going to make or break anyone's day. The real resistance came from the asphalt industry itself. I know, an industry resisting change. Stop the presses. Traditional asphalt producers had been doing things the same way for decades. They had their suppliers, their processes, their equipment. Rubber-modified asphalt meant learning new techniques, possibly investing in new equipment, dealing with new suppliers. Change is hard. Change is expensive. Change is annoying. So some companies pushed back. But the state departments of transportation didn't care about hurt feelings. They cared about building better roads for less money over time. And the data was clear. Rubber-modified asphalt delivered. So specifications started changing. Bids started requiring rubber content. Contractors who didn't adapt got left behind. That's capitalism, baby. Adapt or die. By 2020, the United States was recycling about 76% of scrap tires. 76%. That's up from less than 10% in 1990. The tire waste crisis that seemed unsolvable in the 1980s had been largely solved by the 2010s. Not completely, but largely. And that's pretty remarkable. Let's zoom out for a second and talk about what this means on a national scale. The United States has about 4.2 million miles of paved roads. That's enough to circle the Earth 168 times. If you converted just 10% of those roads to rubber-modified asphalt and used 1,500 tires per lane mile, you'd consume hundreds of millions of tires. You'd create a circular economy where waste becomes infrastructure, where the thing you drove your car on yesterday becomes the thing you drive your car on tomorrow. Other countries took notice. Brazil started using rubber-modified asphalt. China experimented with it. European countries ran pilot programs. South Africa incorporated it into their road network. The technology that started in Arizona in 1989 went global. American innovation solving American problems and then exporting the solution worldwide. It doesn't happen often, but when it does, it's pretty cool. Now here's something most people don't think about. Sound barriers. You know those ugly concrete walls along highways that are supposed to reduce noise? They help, but they're expensive, and they're hideous. Rubber-modified asphalt reduces noise at the source. The road itself becomes quieter. Studies in California showed that neighborhoods next to highways paved with rubber asphalt experienced significantly less noise pollution. People could sleep with their windows open. Property values increased. Quality of life improved. All because someone figured out how to grind up old tires and stick them in the road. There's also the safety factor. Roads with better traction mean fewer accidents. Rubber-modified asphalt provides better grip in wet conditions, which is when most accidents happen. Fewer accidents mean fewer injuries, fewer deaths, lower insurance costs, less strain on emergency services. It's a cascade of benefits that ripple outward from one innovation. The tire industry itself changed because of this. Easier to shred, fewer contaminants, better material separation. The entire life cycle of a tire evolved. From production to use to disposal to reincarnation as a road. It became a closed loop instead of a one-way trip to a landfill. Looking forward, the technology keeps improving. Researchers are experimenting with higher rubber content in asphalt. Some test roads use up to 20% rubber by weight. That's a lot of old tires. Others are exploring different rubber particle sizes to optimize performance. Some are combining crumb rubber with other recycled materials like recycled asphalt pavement and plastic waste. Imagine roads made from old tires, old roads, and old plastic bottles. The ultimate recycling trifecta. There's also potential for smart roads. Embedding sensors in rubber-modified asphalt to monitor traffic, detect ice, measure wear and tear in real time. The flexibility of rubber makes it easier to incorporate these technologies without compromising structural integrity. We might be driving on intelligent highways that communicate with our cars, all made possible because someone figured out what to do with old tires. The economic impact is staggering too. The crumb rubber industry now employs thousands of people, processing facilities, transportation, quality control, research and development. Jobs that didn't exist 30 years ago now support families across the country. State governments save millions on road maintenance. Cities save on noise mitigation. Environmentalists get to celebrate a genuine recycling success story. Everybody wins. Well, almost everybody. Landfill operators probably aren't thrilled. But honestly, screw them. If your business model depends on burying millions of tires that'll sit there for 500 years leaching toxins, maybe it's time for a new business model. So next time you're cruising down the highway, think about what's under your wheels. There's a decent chance you're driving on someone's old Michelin that used to be on a minivan in Cleveland, or a worn-out Goodyear from a pickup truck in Dallas, or a bald Bridgestone from a sedan in Sacramento. Ground up, mixed together, spread across thousands of miles of American roads. It's recycling on a scale so massive it's almost incomprehensible. What started as a desperate attempt to deal with mountains of waste became an infrastructure revolution. Arizona took a chance. California scaled it up. Other states followed. And now, decades later, we've turned one of our biggest environmental problems into one of our most durable assets. The roads we drive on, built from the tires we threw away. That's not just smart engineering. That's American ingenuity at its finest. Taking a problem, flipping it on its head, and making it work for us instead of against us. And the best part? Most people have no idea. They just drive, complaining about traffic and potholes, completely unaware they're participating in one of the largest recycling programs in human history. Sometimes the most revolutionary ideas are the ones hiding in plain sight, right under our tires.